Hello, my name is Qinghua Chen. Here's my answers to problem 1 in homework 6. The first question is to find A so that the above identified is a valid joint density function. So we can do the integration of joint density function of x, y. The integration is 1, so we can figure out the value of A is equal to 4. So the density joint density function is 1 plus x multiplied with y over 4. The second question is to let us judge whether x, y are uncorrelated. First, we can figure out the expectation of x, y. We can use the formula like this, do the integration of this x y multiply with joint PDF of x y. Then we can get the answer is 1/9, and we can figure out the extract of x is equals the integration from -1 to 1 x multiplied with 1 plus xy over 4 dx, and from -1 to 1 dy. Finally, we get the value is 0. So the expectation of xy is not equal to ex multiplied with ey. So xy are not uncorrelated. The third question, as we have judged above that xy are not uncorrelated, so xy are not independent, because we know if xy are independent, xy are sure to be uncorrelated. The first question is to find the joint density function of x square and y square. We can let d equals x square and w equals y square, and we can figure out the Jacobi is equal to 4xy, and we know z is and we know when d is smaller is less than or equals 1 and bigger than or equals 0, and w has the same range. The absolute gi is equal to 4 for the w to the power 1/2. Now we can get the and the I from 1 to 4. This can be valued as 1, 2, 3, 4. So we can now figure out the joint density function of ZW is equal to this. That's the 4 cases that's the 4 cases the different value of x, y. So we can get the answer is this one, and it's only when the and w in this range, and when otherwise the is more less than 0 or the is bigger than 1 and the w is bigger than 1 or w is less than 0, the joint function, the joint density function of dw must be 0. So we can get the density joint function, joint density function of x from x squared and y squared is equal to 1 1 over 4 dw to the power 1/2, and for the smaller than or equals 1 and bigger than or equals 0, and the w is less than or equals 1 and bigger than or equals 0. Otherwise, it's equal to 0. The fifth question is to judge whether x from and x squared and the y squared are independent. We can figure out the joint density function of d and the w. They all have the same similar function, and we can see that f f dw is equal to fd multiplied with fw, so we can know that x squared and y squared are independent.